All right, let's look at 10-79 and figure out option number 2. The problem states, if you win the lottery and you take the payments over time, option 2, the amount you receive each year will form a geometric sequence. It asks, what is the first term? Well, when you think back to the problem, right, we said up here that you would get $1,500,000 first. So that would be our first term. We'll just go ahead and write in there $1,500,000. Okay, it says, what is the growth factor? Well, for option 2, it said it was going to increase by 5% each year. So remember, if you had, like above, we had the 4% increase, right, to make it like 104%, but our multiplier was 1.04. So our growth factor here, since it's going up by 5%, we would be multiplying by 1.05. Okay, so our last part here says write an equation in first term form. So we're going to write out an nth term equation for this, similar to what we did in part B in the previous problem. So we're going to say A sub n should equal our first payment, which is 1,500,000, times that 1.05 raised to the power of n minus 1. Letter B now says, if you take payments over time, option 2, how much will you receive in the 20th year alone? Okay, so we're not trying to figure out how much money we're going to have total in 20 years. We're figuring out this last one right here. How much money are we going to receive? Okay, so let's take it here and let's just use the equation that we came up with. We know that we're trying to find our 20th payment here. So we're going to say A sub 20 is going to equal 1,500,000 times 1.05, and we're going to raise that to the power of 20 minus 1. So you can take that and plug that into the calculator there. I've already done it, so I know what the answer is, but you should end up with 3,790,425.29. Not bad for the last payment that you would receive. Okay, so remember, that's not just how much you have overall, that's how much you're getting in the 20th year with this option. Okay, so let's move on here to part C under option number 2. Oops, I got some stuff in there already. Let me just erase that out. Okay, so remember how all these values are coming to be here. We're going to say, right, we had that A sub n was equal to 1,500,000 times 1.05 to the power of n minus 1. So the first payment there, right, we would take 1 and we'd plug it in. We'd say 1,500,000 times 1.05 to the power of 1 minus 1. Well, 1 minus 1 is 0, and 1.05 to the power of 0 is 1. So we know that that first payment was 1,500,000. We know that, okay? Now, the reason I'm doing this, though, is just to make sure we're comfortable with the rest of them, right? Our second term, then, would be like saying 1,500,000 times 1.05 to the power of 2 minus 1. So basically, we're multiplying 1,500,000 times 1.05. You don't have to write all this down. I'm just trying to make sure that everybody can follow along there. So when you multiply that there, you should get, this would be $1,575,000. Okay, the third one, right, we would take and we just do, our A sub 3, or we know that we're going to end up multiplying times 1.05 twice on this one, right? So you can probably just take this value that you have here and you can multiply it times 1.05 if you want to. Okay, when you do that there, you should get 1,575,000 $653,750. That's our third term in the series. If we're going to get the fourth term, we could take that, multiply that value. This would be like our fourth term. Or you can plug 4 into the equation up here. Either way you want to do it. You should end up with $1,736,437.50. Okay, and then the fifth payment you will get would end up being, like I said, you can plug in the 5 or just multiply this times 1.05, but it would end up being $1,823,259, and I'm going to round it to 38 cents. So you see here, this is the first 5 terms in the series. So each of these, right, you're adding together to have the total amount of money that you've got. So hopefully you're starting to think about which option would I choose if I was in this situation here. And we'll compare these here in the end. Let's go ahead and look at D. It says for option 2, write a general equation to represent the sum of the money received from the lottery for any year after the payouts have started. So now what we're going to be doing here is we're looking for one of our sum equations. Remember, to write the sum equation, there's a couple pieces of information we need to know since it's a geometric series. We need to know what the first term is, and we knew already that is 1,500,000. We need to know what our multiplier or our geometric ratio is. We already know that is 1.05. And we need to know the number of payments. Well, that would end up being 20. So we can create that equation here, right? So remember, that looks like this. This is the general form. S sub n will equal 1,500,000. Oh, I'm sorry, I'm doing the general form. So in this case, it'd be like a sub 1 times r raised to the power of n minus a sub 1, or the first term, and then divided by r minus 1. So for this case here, we would say here that we would have S sub n would equal 1,500,000 times 1.05 raised to the power of n minus 1,500,000 divided by 1.05 minus 1. That is the equation they're looking for here. We can figure out how much money we have in the account by plugging in n to know, whatever year we're looking for. Okay, so that is our answer for D. And now we'll move on to E. It says use your general sum equation to find the total amount received after 20 years. So we'll take this here, and we're just going to take that n is equal to 20 and plug it in. So the sum of the money after 20 years will be 1,500,000 times 1.05 to the 20th power minus 1.5 million, and then all divided by 1.05 minus 1. And you can do that any which way you wish there. You can just, type it all into the calculator if you want. I'm going to do that here. Let's do 1,500,000 times 1.05. Raising that to the 20th. Make sure you're careful about how many zeros you put in those numbers, and make sure that you aren't hitting the negative sign. You're actually using the subtraction there. So our answer will be, looks like we're going to get $49,598,931.15. Awesome. So let's put that down here. So $49,598,931.15. Okay, so you get just a little under the full $50 million if you let them pay it out over 20 years. Okay, now, question F just asks, if you had to choose an option, which one would you choose and why? So that one, there is no right answer. It's just, personal preference there. Being that if you won it when you were younger, maybe you would want to take the payments over 20 years, right? Because, some people get the money and they blow it all, when they're young, and they don't have anything when they're old. So if you're young, maybe you take the 20-year option. If you're old, you know what I mean? You may not be around for 20 years. So maybe you go ahead and take that lump sum and you roll with it there, right? Have some money to play with. Okay, so this is the end of the lottery problem there. Remember, there is no correct answer. It's whatever you choose on F. If you have questions, please reach out to your teacher there. We'll gladly answer anything that you have. But we'll see you in the next problem.